Alright guys, find the area of a region enclosed by the following given curve. Y equals fx minus x squared and the line x plus y minus 8. Okie dokie. Here's what I'm thinking. If the line was on its own, what area would you have? You'd have this blue area here, wouldn't you? Does that make sense? If you integrated the line, so if I integrate the line now, do you notice that the line hasn't got y on its own yet? So how do you get y on its own for the line? Move the x and the 8 over the other side. So anybody getting y equals 8 minus x? Is that right with you guys? So we go for 8 minus x dx. Where does it start from? 2. Where does it end? 4. 2 to 4. That's that blue region there. Is everybody happy with that? So this one here, that's that blue region there. Now next thing, we're going to get the area underneath the curve. And the area underneath the curve will be this yellow region here. Everybody cool with that? And then, when we do the yellow region, take away the blue region, we get the shaded region on top, don't we? And that's what we're looking to do. So what's the integral for the yellow region then? Which I'll do in black. Anybody tell me? Thanks for the help, lads. Now, very enthusiastic. That's the function there, isn't it? 5x minus x squared dx. And we take the blue region away from the yellow region and we get the shaded region. This is pretty handy actually. It's not so bad. Alright, let's do this. What happens when you integrate 5x, Oscar? What you get?
5x squared over 2.
Well done, 5x squared over 2. And what happens when you integrate x squared?
X cubed over 3.
Yeah, man knows his stuff. Okay, Killian, what happens when you integrate 8?
8x.
Integrate x.
X squared over 2.
And it's 4 and 2. Alright guys, so what do we get next? So lob in the 4 and the 2. So 5 times 4 squared over 2 minus 4 cubed over 3. Take away the 2 then, so 5 times 2 squared over 2 minus 2 to the power 3 over 3. Alright, just so you know, see this part here, the yellow part? That's all of this. Okay? So we could do them separately. What you get when you lob all that in? Anybody know? Was it? 34 over 3. Is everybody alright with 34 over 3? Alright, next we're going to do the blue part from earlier. Just the blue part here. And we're going to take away that blue part from the yellow part. And I'll do it down here. So it's minus all of this, which is going to be 8 times 4 minus 4 squared over 2. And it's in its own set of brackets. Take away, what is that? 8 times 2 minus 2 squared over 2. Alright, lob all that into the calculator, figure out what it is, and we're going to take it away from 34 over 3. What did you get for that part? Huh? Who got 10? Good man. Alright. Big Mick has it. It's guaranteed. Now, what's next? 34 over 3, take away 10. 4 over 3. And we get 4 over 3. Well done. Alright. Any questions? No. If you're ever faced with a question like this in an exam, pick the easiest part first and get marks on the board. Okay? So which part's the easy part? A1. A1 is the easy part. Okay? So just target A1 and go after that. Now we're going to have to find P and Q first, is it? P and 0. Now, here's what we're going to do. We're going to put the two y values equal to each other, is that right? So we're going to have minus 2x equals 2x minus x squared. Bring it over and we get 4x minus x squared equals 0. Assuming a good H2 class will mostly get these two answers here. And we get x equals 0 and, anybody, what's the other one? X equals 4, yeah? We knew one of them was 0 because it happens at the origin. We didn't know that this one was 4. Is that okay? Now, next thing we're going to do is we're going to integrate the curve. And what values are we going to integrate the curve from, Phelan? 0 to? 0 to 4, and we're going to integrate this guy here. Okay, go on, tell me what you get. What happens when you integrate it?
You get 2 over 3, x squared minus x cubed over 3.
When you differentiate x squared, it turns back into 2x, and you said x3 over 3?
Yeah.
And that's from 4 to 0, and that will result in 4 squared minus 4 cubed over 3. Are we expecting a positive or negative answer? Is it above or below the x-axis? Above. So we're fully expecting a positive answer. And what you get, Phelan? Oh, Oliver, what you get?
Minus 16 over 3.
Minus?
Just
16 over 3. Alright, I'm going to put this in the calculator. I sense nerves. He's probably right though. He is, Oliver. It is minus 16 over 3. Interesting. So why is that? It's above the axis and it's negative. Interesting. It's a U-shape, it's an N-shaped function though, isn't it? What? No, we're in this region here.
Roughly 0 to 2 then. 0 to 4.
Oh, there we go. Yeah, numpty. Absolute numpty. See what I did there? I went 0 to 4. Which means I actually got A1 combined with, call it A3, this area here. I got A1 combined with A3. Well, I should have actually figured out where does it cross the x axis. So I actually have to put 2x minus x squared equal to 0. Is that alright? And you take out x and you get. But wasn't it great that I knew I was wrong? Do you get what I'm saying? I knew that I was expecting a positive answer. I got a negative answer. And I knew something was up straight away. And then we went looking for it. That's what actually happens in an exam, isn't it? Sometimes you just rush stuff and that's what happens. See, we got x equals 0 and then x equals 2. And you know the great thing is it's a quick fix. So what's the only thing you need to do here? Just change that to 2. Okay. Take out the old tip x. And then just lob in 2's instead. And go again. And what you get this time? 4 minus 8 over 3, which would be 4 over 3. Happy days. We all cool with that? So the answer for A1 is 4 over 3. All good? Now, next thing. Okay, so we got A1, which is 4 over 3. Okay, now what I'm going to go after next is this. I'm going to go after the full triangle. Full triangle being this guy here. So this full triangle here. Everybody cool with that? Oh, look at that. Terrible. There we go, there's the triangle. Okay? So how do I get the area of this triangle? From what to what? Where does that triangle start? 0. Where does it end? 4. What function am I using? Y equals minus 2x dx. We're expecting a positive or a negative value. So that means I should consider using the modulus sign, shouldn't I? Okay, has to be a positive value. Now, what do I do if I use this region here? How do I get the area of this region here? Oh, sorry, different colour. Different colour. So if I use this region here, how do I get the area of that yellow region? Anybody? Where do I start? X equals 2. Ends at 4. What function? Okay. Positive or negative once I get the answer? It's negative all day long. Is that alright? So once again, I'm going to consider using the modulus signs. When you take one answer away from the other, oh, it almost worked. Almost was slick. So when I bring that over there, what's left over? A2, the shaded region A2. That's A2 there. Everybody sees it? A2 is like the blue region. Okay? So, integrate them, treat them as positive, take them away from each other, you get A2, then you add A2 to A1, and you're gold. Let's keep going. Carol, when you integrate minus 2x, from 4 to 0, right? Then after this then? So x squared again, yeah? And here? From 4 to 2, alright? Okay, let's begin. Now we're going to treat these two parts separately to each other. It's going to be, would everybody be happy with minus 4 squared minus 0 squared, which is minus 16, which for us is 16. Take away, what's it, 4 squared minus 4 cubed over 3. Take away 2 squared minus 2 cubed over 3. Anybody got that second one handy? Huh? Minus 20 over 3, I'll take that. We knew it was going to be negative, didn't we? So, in this case, minus times minus is not a plus, isn't it? Because we're not treating that as minus 20 over 3, we're treating that as plus 20 over 3. Because no area is negative. 16 minus 20 over 3, anybody? 28 over 3? Your 28 over 3 is the area of A2. Your 4 over 3 is the area of A1. Add A1 to A2 to get 32 over 3 as your answer. Who got full marks on that last night? Alright. Lads, if you're remembering the test, please do just write down square units at the end. Now what square units means is you don't know whether they're meters squared, centimeters squared or kilometers squared. So you're just saying whatever units it is, it's square units. Try and put it down every time. And then you take out the marking scheme. At worst they might take a mark off you. But just remember to write down square units every time. Alright. Oh, you guys have a go at this one. Alright guys. First thing you're going to do is find your starting points. You notice that your U-shaped curve only hits the axis once. So you're going to replace y with 0. Yeah? Ah yes, just give me a sec. The x-axis is the line, x equals 0 and 2x is 4 times. Alright, so you don't even need that. Somebody leading me down a rabbit hole. Good old CG. Alright guys, so what they're essentially saying is that A1 and A2 are your two competing areas. Is that alright? And A1 is the yellow area, A2 is the green area. And what they're sort of saying is that the green area is between from total value of k. So the x-axis lines, these two, is 4 times. Oh, thank you. Total area, not just the starting off point. So yellow plus green, yeah. Yellow plus green is 4 times yellow. Is that alright? So here we go. Yellow plus green equals 4 times yellow. Is that alright? That's your formula. Okay. Now how do you get the yellow plus green area in one swoop? Integrate it all the way from 0 up to 2k. Is that alright? So it's x squared plus 4x plus 4 dx. That gets you the yellow area plus the green area. But we know that this is equal to 4 times the yellow area only. So that's 4 times k to 0 of x squared plus 4x plus 4 dx. If you have the answer correct and you're waiting on me, go to 24. Now, don't want to bore you. Alrighty. James, what do you get for x squared when you integrate it?
3
Alright, and 4x? 4x squared over 2, which is? 2x squared, yeah. And 4? Nice things about these questions is that both integrals are the same. So happy out. From this one's just k to 0, isn't it? Alright. Now, let's put in our stuff. We don't need to worry about the second limit at all, do we? It's only ever 0, isn't it? So we're going to get 2k to the power 3 over 3 plus 2 times 2k squared plus 4 times 2k, and then over this side it's going to be k cubed over 3 plus what's it, 2k squared plus 4k and k to 0. Oh sorry, we already did k to 0 minus the 0, alright? What am I forgetting here? There's a 4 on the outside, isn't there? So remember we said earlier, the area of the yellow plus the green is 4 times the area of the yellow on its own. Alright. Looks like the ending will be quite complicated, so here we go. 2k to the power 3, anybody? K cubed plus 8k squared plus 8k equals, that's going to be 4k cubed over 3. Next one, 8k squared, thank you. Alright, this is not as complicated as I feared it would be. For what reason? They cancel. So that's a very good thing. 8 over 3 minus 4 over 3. 4k cubed over 3. Bring the 16k over. You get minus 8k. Now, alright, what can you take out in common? Huh? Okay with that? Alright, we have an answer of k equals 0. Okay. Now we now have to solve 4k squared over 3 minus 8 equals 0. Common denominator of 3 divided by 4. K squared equals 6. K can equal plus or minus root 6. Which one is it? Plus or minus root 6? Is K to the right of the origin or to the left of the origin? Did anybody get K equals root 6? Alright, good job. Let's attack it, okay? Y equals e to the x, y equals minus e to the x. E to the x is the red one going upwards. Minus e to the x is now my blue one going downwards. Okay, we good with that? Blue, not green. Blue. Find the area of region P. Alright. Are we pinned against the x-axis or the y-axis? We're pinned against the y-axis. Okay? So, purple dots. What's the value of the lower purple dot? 1. What's the value of the higher purple dot? E. Integral of 1 to e. X dy. What's my issue? I have y equals e to the x. I need to get x on its own. How'd you get x on its own, Killian? ln both sides. Happy days. And then use the what rule? And what's x ln e? Yeah, because ln e is 1. So the actual thing is x equals ln y. So we're now doing the integral of e to 1 ln y to y. You all cool with that? Alrighty. So, oh yeah, this one's tricky, but I think we'll get it. Yeah, I have an idea. Alright. So, what happens when you integrate ln? Is it just 1 over y, or what is it? What? Is it 1 over y? Not when you differentiate it, when you integrate it. What does it say in the tables? What does it say? Doesn't have it.
No. It's got 1 over x is ln x when you integrate.
What?
Doesn't have it yet.
That's true. Is it integral of e to the x is not e to the x?
What?
Is the integral of e to the x not e to the x?
Yeah, but I don't have e to the x. I have to get x on its own. Just give me a sec. Once again, this is all learning, alright? Shh. If you choose to do that way, we're now stuck with an integral that you guys haven't covered on the course, correct? What would that tell you? Go back to the start and choose a different path. So don't persevere. Just say, okay, that hasn't been covered on our course, not covered on the Leaving Cert course anymore. Go back up and go, do you know what? Pinning against the y-axis is probably not the best idea. Is that alright? Let's try another way. And the other way is quite obvious. Now that I'm looking at it, it's quite obvious. What happens if I do the area of a rectangle? It's a rectangle, isn't it? So, I'll show you what I mean by the rectangle. What about this area here? Yeah? Everybody cool with that? What is the area of that? How tall is it? It's E tall, and how far across is it? 1. Alright, that's handy. The area of that rectangle is E. Now what can I do then? What's the area underneath the top curve if I pin it against the x-axis? Just stay with me for 1 second. How do I get that area? What do I need to take away? 0 to 1, e to the x, dx. Not so bad anymore, is it? No. Do it that way for the weekend. So, for the weekend you're going to do 24 23, 22, 17, 17, 22, 23, 24. Yeah.